Welcome to the last topic on regression and correlation. This perhaps is our last topic under biostatistics, that is topic number 5. This concept of regression and correlation widely features in any research activity. So we have the opportunity now of going through the concepts that are strongly related and get an appreciation of where they are used, how they are used in the various research scenarios. So by the end of this lesson, I expect you to be able to explain the purpose of regression and correlation analysis. Compute and explain the meaning of correlation coefficients, coefficient of determination, as well as compute the regression equation and use this to measure, to do estimates, that is to estimate. Now, let me start from the onset by defining what regression is. What is regression? Now, regression is a statistical technique. It is a statistical technique. What is this technique all about? Statistical technique of establishing a relationship. A relationship, perhaps here, maybe I should underline the word relationship, because between or among variables. Between or among variables. A statistical technique of establishing a relationship between or among variables. So what comes into mind here is the fact that when we talk of between, we'll be having two variables. So regression can involve only two variables. Only two variables. Of course, we won't have one variable. So we can either have only two variables, or it can involve more than two variables. So I'm just trying to explain the words that I've used. So if two, that's when we have only two variables, we are talking of between. When we have more than two, of course, we are talking of among. So now maybe I should just give some. Yeah, so what is clear here is that regression can involve two variables only, or more than two variables. So that technique where we are trying to establish whether there is a relationship or there is no relationship between two variables is what we refer to as regression. Now, what is correlation? So this is very, very important, because here we need to get a clear picture of the differences between regression and correlation. So correlation, we attempt to establish the strength of the relationship. Now here, what is clear is that regression, we establish whether there is a relationship. So correlation is to establish how strong is that relationship. You see, when we talk in everyday life, we can say two people are friends. So that aspect of trying to figure out if a particular person A and B are friends is what we call regression. Now, when we go a step further to say, but how strong is their relationship? That is when we use correlation. Now, I think at this particular point, it is important for me to just give a simple scenario, everyday scenarios. For example, you would realize that, let me give this as examples of variables where regression can be used. In agriculture, we talk of yield versus area under crops. So in this case, you would realize that the bigger the area cultivated, the more likely you expect yield to go up. So yield is a variable. We are connecting it to area cultivated. Variable 1, so this is variable 2. So we want to see if there is a relationship between yield and the area cultivated. Now, another simple example, let me perhaps give this in fisheries. We might have, for instance, let me say we have an aquaculture. We are keeping some fish in a pond. So we may want to regress amount of feed that is given or that is applied to the pond versus weight gain of the fish. So all these are variables. So whenever we are trying to establish the relationship between the variables, we call that regression. Now let's move further to look at types of variables that are involved in regression. Types of variables. Now, in regression, we have what we call the dependent variable. The dependent variable is usually denoted by y. That is number 1. And we also have what we call the independent or explanatory or independent variable. Now, this independent variable is denoted by x. So explanatory or independent variable, in economics, they call this explanatory or independent variable an exogenous variable. Maybe I should add this. Whereas the dependent is called the response or simply an endogenous. This endogenous is used in economics terminology. So these are the groups of variables where a relationship seeks to be established. A dependent variable and an independent variable. Now, maybe we need to go further and sort of highlight some few aspects here. Now, we know that when it's hot, on a very hot day, people normally buy a lot of ice creams. So if we have a daily temperature versus the ice cream sales. Versus ice cream sales. What would be our dependent variable and which one is independent here? So that is very, very important because sometimes you are not given which one is the dependent and which one is independent. You are asked to fit a regression equation. So you need to know which one in any given scenario would be dependent and which one would be independent. Now, in this case, we ask ourselves, daily temperature. Daily temperature, you can see that obviously that one is independent. So this becomes our X. And the dependent becomes Y. In other words, cells depends on what is the temperature in a given day. You can't talk of temperature depending on cells. How can cells alter temperature? But it is the temperature that alters the ice cream cells. Now, another good example maybe is body mass. Body mass versus calorie intake. Obviously, it is the amount of calorie intake that will affect your body mass. So body mass responds to calorie intake. So body mass becomes our Y, whereas calorie intake becomes our X. It's not the other way around. Now, the number of electrical gadgets in a household and the usage, electrical usage per day. So obviously somebody with just a fridge in a house will do not consume a lot of electricity. Whereas if we've got a fridge, a washing machine, a radio, a television, and so forth, the more the number of gadgets, we expect more usage of electricity. So the question is, are you in a position to determine which one is the dependent variable and which one is the independent variable in any given scenario? Right. So we have so many examples. Think of so many variables that you can model. Now, now that we've appreciated the concept of dependent and independent variables, I want us to go further. When we talk of two variables only, when we have two variables, we talk of what we call simple regression. Simple regression involves only two variables. But when we have more than two, we talk of multiple regression. Now, in most cases, relationships between or among variables are not always linear. That is very, very important. Relationships between or among variables are not always linear. What do we mean here? Now, let me say, for example, we are trying to regress to find a relationship between y and x. We say the relationship is linear if, for example, there is a straight line relationship that exists between y and x. But if we have a relationship, let me use a different pen. If we have a curve like this cannot be said to be linear, or we might have something like this. Surely that is not a linear relationship. So regression can be linear or non-linear. So we may have a simple linear or a simple non-linear or multiple linear regression or multiple non-linear regression. And in our case now, we shall focus on linear regression. We shall focus on linear regression where we have a straight line. The word linear comes from line. Straight line relationship between y and x. Now, what I want us to look at is in this linear relationship, what is the model? Statistical model y is equal to beta naught plus beta 1 x plus the error term e. So this is the assumed relationship between y and x. We remember, I think in some lower grades, we used to say equation of a straight line is y is equal to mx plus c, and we would say y is the one of the variables, m is the slope, and the c is the intercept. I think we used to talk much about the equation of a line. So this is the same, except that here we've used beta naught and beta 1. In some textbooks, you will find y is equal to a plus b, x plus the error term e. All these, they represent a simple linear regression model. Now, I want to leave an assignment for you. What are the assumptions? What are the assumptions of this? Assumptions of the model. This is an important question. Let's make sure you appreciate. Of course, one of the assumptions is that there is a linear relationship between y and x. So we assume that there is a linear relationship between y and x. But I want you to state these assumptions, at least four assumptions of the linear, simple linear regression model. Now, I want us to go further with regression. We are going to focus on correlation later. So what I'm going to do now is to give a very simple example and check how do we go about regressing y on x and so forth. Now, I will do this through a simple example. So let me call this example 1. Perhaps that is example 1. We want to answer the following. You timed how long it takes for 10 workers to assemble an item. The purpose was to check the effect of experience. In other words, we want to answer the question, does experience really affect the time it takes for a particular individual to assemble a particular item? I think it's important for me to put this question. What is the effect of experience on item assemble time or duration? This is a big question. So from this question, even if you are not given which one is the dependent and which one is the independent, I expect you to be able to establish which one is the dependent and which one is the independent. So now suppose you collected data. So experience, which is now your X, and the time is in minutes. This should now be your Y. So what we will have, we say we have 2, 5, 3, 8, 5, 9, 12, 16, 1, and 6. Then for your Y, we have 27, 26, 30, 20, 22, 20, 16, 15, 30, and 19. Now the question is, use the least squares regression technique to fit the regression equation Y equal to beta naught plus beta 1x. So this is the equation that you are required to fit using the least squares regression technique. You know, normally such a question would have up to 8 marks or so, or even more. So how do we go about? Now, let me put some few notes here. I want you to try and read a bit about the meaning of least squares. I'm not going to explain it here. I will leave that to you. But using that, Y is equal to beta naught plus beta 1x. That is the simple linear regression. What is beta naught? Beta naught is equal to summation of y over n minus b, the summation of x over n, which is the same as y bar minus b beta naught 1 x bar. You will see this formula is normally provided for you, so you don't need to memorize. But what is beta 1 hat? Beta 1 hat is equal to n, the summation of xy minus summation of x times summation of y divided by n, the summation of x squared minus summation of x, all this squared. Again, this formula is provided. What I want you to take note of is that, first of all, you need to find beta 1. You see, beta 1 hat is an estimate of beta 1. So beta naught hat is an estimate of beta naught. So the beta naught and beta 1, without a hat on top, they are called the population regression coefficients. So you need to use the sample regression coefficients to estimate the population coefficients. So that these are the least squares regression formulas that you must use to estimate beta naught and beta 1 given a particular data set. Now, with that in mind, if you are given data like this, looking closely at these formulas, let me try and, yeah. Looking at these formulas, you do realize that you have x, you have y. So when you add this column, you get summation of x. When you add, maybe let me use a separate, a clean sheet here. Let me use a clean sheet because this is very, very important. So we have got our x and we've got our y. So our x is 2, 5, 3, 8, 5, 9, 12, 16, 1, 6. Y is 27, 26, 30, 20, 22, 20, 16, 15, 30, and 19. But what is our formula for beta 1 hat? Is equal to n, the summation of x, y minus summation of x, summation of y, divided by n summation of x squared minus summation of x, all this squared. Like I said, this formula you are provided. But from this table, we need to construct that formula. So here, when we add, let me write, I will add and write. So when you add 2 plus 5 plus 3 plus 8 plus 5 plus 9 plus 12 plus 16, you must get 67. So this is the summation of x. It's just adding the numbers downwards. Now, what is summation of y? Summation of y, if you add downward, you get 225. So you put on your calculator and you add. Now, what is the next? So here, we have this. We've managed to find that summation of x, summation of y. But where is this item, summation of xy? Summation of xy, you must first of all get the product, which is xy. So xy, you are multiplying this times this, 2 times 27, I think you get 54. 5 times 26, you get 130. 3 times 30, you get 90. 8 times 20, you get 160. 5 times 22, you get 110. 9 times 20, you get 180. 12 times 16, you get 192. 15 times 16, you get 240. 1 times 30, you get 30. And the final one, 6 times 19, you get 114. Right? So again, we would want, because check the formula that we are constructing, we would want summation of xy. You see, now we are adding this last column. So the first thing is to get this times this, this times this. We are multiplying each to get xy. Now we add downwards. We are going to get 1,300. Now, what else do we want? So we now have this one summation of xy. But what about this one? That one we don't have yet. So we need to construct it, summation of x squared. So we need to get x squared. So x squared, we are squaring each number here, which is 2 squared 4, 5 squared 25, 3 squared, which is 9, 8 squared, which is 64, 5 squared is 5 squared is 25, 9 squared is 81, 12 squared is 144, 16 squared is 256, 1 squared is 1, 6 squared is 36. So here now, to get this component, we need to add. So this will be summation of x squared. Now the summation of x squared, now we are adding these numbers. So there we are going to get 645. So I think we almost have every component in our formula. So our beta 1 hat will be equal to, what is our n? N is 10. You see, we are looking at the pair. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 multiplied by summation of xy, which is 1,300, minus summation of x, which is 67, summation of y2, 25, divided by 10, multiplied by summation of x squared, which is 645, minus summation of x squared, which is 67 squared. Now, so you calculate the top part, then you divide by the bottom part, you must get minus 1.06. That is our beta. That is our beta 1 hat. Now, how do we get beta naught hat? We said this is equal to summation of y over n minus beta 1 hat summation of x over n. What is summation of y? Summation of y we already have from our table. It's 225 divided by 10 minus, now our beta, you see this is the value that we found. So that will be minus 1.06. Summation of x is 67 divided by 10. Now, if we calculate this, we are going to get 29.60. So our estimated regression equation, becomes, now we have those values, y is equal to beta naught. What is our beta naught? 29.60 minus 1.06. What is our x? Right. So that is our regression equation. Now, what does this regression equation represent? What does it say to us? So the value, now the value of beta naught in this case, which is 29, represents the y-intercept. That is the point on the y-axis when x is equal to 0. So what does that mean in the context of what the problem that we are given? When someone does not have an experience, does not have any experience, what does this mean? For someone with no experience, that is when x is equal to 0. Remember, experience represents 0. Experience is represented by x. So when someone does not have experience, then he takes 29.60 to assemble the item. So that is when x is 0. For somebody who has no experience at all, that person will take about 29.60 to assemble the item. Then, what happens for somebody with experience? Now, if these are months, one should realize that for every unit increase, for every monthly increase in experience, the time to assemble the item will reduce by 1.06. So when x is equal to 1, the time, which is y, that will be taken to assemble the item will be 29.60 minus 1.06 times 1. So as you see, this model tells us that the more there is an increase in experience, monthly experience, we expect the time taken to be going down because of this negative. Because of this negative. Remember, we will put x is equal to 1. We put x is equal to 2. For a worker with 4 months experience, it means x is equal to 4. So 4 multiplied by 1.0, it will be 29 minus almost 4 point something. So that is how this regression model works. So colleagues, what we've done so far, we've introduced briefly what regression and correlation is. Now we've gone on to explain the concept of dependent and independent variables. And then we used a couple of examples to show these different types of dependent and independent variables which can arise. Then we gave an assignment on the assumption of the simple linear regression model. Then we went on to give a numerical example to try and explain the least squares regression technique. Please, I want to end here for this particular video. Tomorrow, or the next segment, that is the second recording, will definitely cover correlational analysis. So go through this video, do as many examples as you can under regression, use of least squares. So the most important thing is for you to know how to use those formulas. Make sure you are able to identify which one is the dependent and which one is the independent variable. Then your dependent variable becomes your y, independent variable becomes your x. Thank you very much. Wait for the second segment, the second and last, that is a correlation analysis. Thank you so much.